So question 3 is a network with a precedence table. And the first question that they want us to think about here is what's going on with the dummy. Why do we need a dummy? Now, for 2 marks, we're going to have to include quite a bit of information here. And you want to include, so your dummy link starts here, so it's coming up from C. And you can see where it points to. It's pointing to being a prerequisite for both G and F, as well as being down here for prerequisite for E. So we have to talk about those things. So we'll start off with E. So we'll say that E has a prerequisite of only C, but we have both G and F have a prerequisite of D and C. Okay, and there's your 2 marks. So think about where the dummy link is coming from and then where it's going to. It's all about the prerequisites for when they ask you why a dummy link is required. But come down here, they've got the precedence table has been completed. Now it is for the above network diagram, and so they've got the EST is your early start time, LST is your latest start time, and it's saying that the network diagram above should have 2 dummy links, and it's saying use the information in the table to find and draw the second dummy link. So if you look through, remember that a dummy link is required when some tasks have some but not all prerequisites the same. So for instance, here's our C with our CD one that is actually up above, and then the one that we do need, I might do this one in a different color, it looks like. So J and K, they both have G as a prerequisite, but H is the additional one for J. So if we look up here, oops, I might just make it just a tiny bit littler. So G is the one that they both share, so it's got to come from G and it's got to come down here towards task J, because J is the one that needs G as a prerequisite as well. So it's important that we have our arrows, okay, when we add this to the diagram for 2 marks. Using the information in the precedence table and the network diagram, so you can use both, identify which statements. So we're after the correct, and you can have all correct here. So if you've got a highlighter, probably it's a better option than underlining all the time. Task H is on a critical path. So if we've got task H, I'm coming through here, and because the early start time and the latest start time is the same, it means that yes, H is on the critical path, so that has to be true. We'll just write here that slack equals 0. A delay in the completion for task D will always cause a delay in task F. D and F. So up here in the thing, we've got D. So a delay in D will cause a delay in F. Well, not necessarily, because we've also got C coming through here as well, so which is down here. So I would be saying for this one it's not true. I'll just write here, you don't have to put reasons obviously, but and I'm going to say because of C. Task F has 2 days of slack time, so if we go back up here to task F, your slack here, if you just maybe make another column, slack is equal to just 1. So that one is not true. And a delay in the completion of task E will increase the minimum completion time for the network. So if we go to E, again, we're looking for here, and so they've got a slack time of 0, which means it's on the critical path, which means that yes, it is going to be true. Yes, because it's on the critical path. And then it's saying, well, what is the critical path and what's the minimum completion time? So if we're looking at the critical path, we want the earliest start time and the latest start time to be the same. Or we're just checking for the slack. So the slack is your LST, take your EST. I'm just going to fill this in first because it's going to help us identify the path. 2, we've already got the 1. 12 take 9 is 3. We've got 0, 0, and 4. So anything with a 0 on it is going to be on the critical path. So if we're looking through here, we've got A. Oh, what's it doing that? We've got A. We've got C, E, and then H and J. Oh, I can't highlight J, but you know it's there. Okay, and then if we're going up to the network, we can see we've got A. Oh, something's run out. C. So it's A, C, and then we've got E, H, and then J. So A, C, E, H, J is what we're going to write down here. A, C, E, H, and J, and the minimum completion time. Minimum is just us getting that information from the table about how long it or how many days it takes to complete those tasks. So we can see here adding 5, 4, 2, 3, and 3. So 5 plus 4 plus 2 plus 3 plus 3. I don't think we need a calculator for that one. We can pretty much see that it's going to be 17 days. And that is it. Okay, so question 4 is a financial question. It's got some superannuation, some pension annuity, and then inflation in it. So 17 marks. Okay, we're starting off with Nia. It's her first job. Now we're going to highlight all the important information here. So it's 67,500 per year is what she's earning. She's her employer's going to put in 11.5% into her super, but then she's going to pay an extra 1% on top of that into the same account. Okay, so they're the important bits for now. With one little extra thing here though, in the superannuation account, it's expected to earn 7.2% per annum, and it's going to be compounding fortnightly. Now, given all this, part A is coming in at saying, okay, show that. So show that question. Show that approximately $325 per fortnight is deposited into Nina's superannuation account. Now, what's happening here is the percent that's going in is going to be 11.5% from the employer plus 1% that Nina's put in extra. So it's going to be 12.5% is going in. Now, to actually calculate that, the deposit, I guess, if you like, is going to equal 0.125. So that's the 12.5% times by the $67,500 that she's earning. But that will be per year. And so then we just have to divide that into the 26 fortnights that happen each year. So over in the calculator, 0.125 times by the 67,500 divided by the 26, and it's equal to 324.52, which is approximately $325, as we were asked to show in the question, which is great. Coming down to part 2, calculate the balance on Nia's superannuation account after 40 years. So if she keeps putting in this $324.52, how much does she have after 40 years of working in this job? So again, it is 40 years and it's going to be fortnightly. So 40 times 26. The interest rate was 7.2. Because it's her first job, you're assuming there's $0 in that account, but she is putting in $324.52. So it's a negative because Nia's paying into this account, and we want the future value. So from menu, we're going to go looking for that finance topic, compound interest. So it's going to be 40 times 26. Let's just write that down in case we need it later. 7.20. All right, so she's putting negative $324.52 cents. The future value is what we're trying to find, and we know we've got 26 fortnights in a year. So if we press F5 to solve for the future value, what we get is 1,962,134, and then we've got 39 cents. So that's going to be our balance in 40 years' time. Calculate the amount of interest that NIA's superannuation account is got over that 40 years, and it's only 1 mark, so we're going to use the amortization function, which means that we have PM1 and PM, or payment 1 and payment 2, like when do they start and stop essentially for this interest. So we want to know what the interest is between the first payment and the 1,040th payment, if you like. So over on the calculator, we're going to go F4 for amortization. We're just going to make sure that PM1 and PM2 are set to what we are after here. And we're going to use the sum of int. So you have to write down which function you're using here. And what do we get? We get, so the interest that she's earned is 1,624,633.59. Now I've kind of pre-filled these ones to make things a little bit easier for us here, but we only need one reason. You can see I've got a few more there just in case you're thinking a little bit differently to what my first option would be, but these are mine. I'm saying if interest rates go down, then NIA's superannuation account could be lower. If she takes time off work, for instance, maternity leave, that would reduce her balance in her superannuation account. And then she might not decide to contribute an extra 1%, she might reduce that amount or not contribute at all. So that would also make her balance lower. Now, what we have to be careful of in part 2 is this is a hence question. So whatever we've written up above, we have to make sure that our answer below is kind of related. So for instance, if we say, well, interest rates go down, then what we could do to get for Nia to keep her same balance is that she could find a bank with a higher interest rate, okay, to kind of supplement. If we said one of the other two, so either this one or this one, then I think this answer here could cover both. So she could just find a higher paying job or a promotion either after her maternity leave, or if she's decided to reduce those contributions. This solution could keep that balance to be the same. So hence there is the important word when you're thinking about part 2. If we're flipping the page, we've got Nia is now going to be at retirement, and she's got $2 million in her annuity account, and she's got an interest rate of 4.6 per annum, and it's going to be compounding weekly. And she's also going to withdraw weekly from this account for 30 years into her retirement. So we've got another show that question. So we're going to say show that Nia can withdraw a weekly income of this guy here. So this is our payment that we're actually trying to find here. So it was at 30 years and it was going to be weekly. So there's 52 weeks in a year. The interest rate was at 4.6% in this annuity. She was going to put into the account $2 million, hence the negative. Payment is what I said we were going to try to find, and we want it to be 2,365-ish. And future value is going to be 0. Okay, so solving for this, let me just get back. All right, so 30 times 52, we're going to write that down, is 1,560. So it's 4.6% in this annuity. We've given the bank $2 million. Payments we're finding, we're going to withdraw till she gets to $0, and then we've got weekly happening here. So our payment is going to be a 2364.43, which is approximately 2365 as required. Perfect. Okay, calculate the time taken in years for the balance of the annuity to reach $1 million. Okay, so remember she starts with 2 million here, and so we want to know how long is it going to take to get to half of that amount. And it is a time taken, so we are going to find N. We've still got that 4.6%. We still gave 2 million at the start here. Our payments are going to be the 2364.43. And like I said, we want to know how long it takes us to get, or her to get to $1 million if we're withdrawing and compounding weekly. Okay, so 4.6, 2 million. We'll just make sure we've got the right decimal places here. So remember, it's always dollars and cents. So 43. Oops. The future value was going to be million, 2, 3. And we're still doing everything fortnightly. Okay, so we'll solve for n. So n is going to equal 1030 point. Oh, that looks a bit messy, doesn't it? 1030.03. Now we do round up for this, regardless, because we want to make we'll do it on the next line, because otherwise she won't actually have. Because otherwise we'll be short. We won't actually reach the $1 million if we don't round up. We still have a little bit over. So it's going to be 1031 weeks here. And the question, just be careful the question here, because it does say the time taken in years, so you can't actually leave your answer in weeks. So if we just quickly go back here and we go 1031 and we divide this by 52. So it's going to be equal to 19.8 years. Done. Okay, again, I've pre-answered this a little bit, but it says, using mathematical reasoning, explain why your answer in part C part 2, is not halfway through the expected 30-year term loan. So what they're essentially saying here, if I just change my pen back so I can scroll, is that we've gone from $2 million up here down to 1 million, and would expect, if it's a 30-year loan, you might expect that it's going to take us 15 years to get there, but it doesn't. It takes 19.8. So we have to kind of say, well, why is that the case? And what we're saying in my words down here, I'm saying when the balance is high, so at the start of the withdrawal, or the pension, the interest generated also high. Okay, and so this means that the balance is going to reduce slowly because we're generating a lot of interest. But later the balance falls. When the balance is less, then we've got less interest being generated, and so the balance in the account or the principal in the account is dropping off quickly as well. So you have to address both of those for 2 marks, kind of like the first half and the second half. Okay, next part of the question. Okay, so Nia here has decided that her initial cost of living is $1,000 per week, and she wants to maintain that standard of living all the way through her retirement. So we start off, they tell us that it can actually be given by this equation here, where the cost of living is $1,000 times by the 1.031, so it's essentially 3.1% inflation, and then T is going to be the time. Given all that, we have to kind of fill in some blanks here. So it says the value of the 1.031 indicates the cost of living is expected to increase by 3.1%. Now, we know it's an increase because of the 1 out the front, and the 3.1 percentage is found by saying it's 1.031 minus 1, which is going to be, and then we have to times it by 100. Is equal to the 3.1. This term is a measure used to describe, well, I've kind of gave that away earlier, and I said that it was going to be, it's inflation that we're talking about here. So using the equation from part D, I predict Nina's weekly cost of living exactly 5 years into her retirement. So for this question here, we've got T is equal to 5, and so C is equal to, well, is that 1,000? Times by 1.031 up to the power of 5. Okay, so it's going to equal 1164.91 dollars per week. Predict the time in years it would take for Nina's cost of living to reach 2365. So that's when C is equal to 2365. And we're going to actually solve for t this time. So it's 1000 times by 1.031 up to the power of t. Now you're going to use solve n to do that. Oh, so option, calc, solve n, and you just want 2365, oops, equals 1000, 1.031. You've got to use the x button because that t is a different t altogether. Okay, and it turns out that t is equal to 28.2 years. So it's going to take 28.2 years for her cost of living to reach $2,365 per week, given inflation. Okay, this next question here is saying, provide one reason why it's considered reasonable for Nia to maintain her standard of living throughout the 30 years. Now, we've got to kind of come back up here a little bit for this one. So a couple of pages back, we've got this. Okay, so we've got what Nia's doing is she's withdrawing $2,365 per week right from the start of her pension. Okay, and then what we found afterwards is it's like, well, she doesn't actually need that much money to maintain her standard of living until 28.2 years into her retirement. So she's withdrawing all the money, but she doesn't really need it. So what we then come down here and say is that she has an approximate income of $2,365, which is greater than her required level for the first 28.2 years. And any extra money she doesn't use before that could be used to save for when she's going to need it, say in that last 1.8 years. And that's it. So question 5 is a stats question. It involves linear and exponential models. So the focus here is also going to be on owners that take their cats to visit the vet annually. And you can see in here, for instance, that if the cat is 12 years old, over those 12 years, it's had a cumulative vet cost of $2,500, for instance. So in part A, we're interested in this linear model up here, and it says predict the cumulative vet cost for a 9-year-old cat. Now, when we look in here, we can see we've got the data for 8 and 10, but not 9. So we're going to be using the model to give us that estimate, which means that t is equal to 9, and we're going to, in our calculator, we're going to go 113 times 9 plus the 1,172. And 72. Okay, so we get $2,189, and there is no cents in that one. So that's for the cat that is visiting the vet annually. And then the second set of data is saying that the cat does not visit annually, so it's just the cost for when they get sick as an estimate. So it's saying that it wants you to kind of find the linear. So part A is saying calculate the linear regression equation for the cat that does not visit this vet annually, and we have to obviously fill in the table. So to do that, we're going to go back to menu. You're going to go stats, which is pressing number 2, and you're going to be entering the data in from 0 to 12 years old. I might just pause and fill it myself. So all the data is entered, and I would definitely always 100% check your data that you've entered it correctly before you move on to the actual question. And we are about to do the linear regression to this data set. So we're going to go into calc, and then you want to go regression, so F3, and then it's just the X, which is F1. We always use what's easier to use the AX plus B, which is F1 again, and this is where we get our linear model. So it has to be C is equal to, and it's the 1223.21. We'll use 2 decimal places, and it's times T, and then it's going to be minus 1696.43 as our linear model. Again, 2 decimal places in this case is quite sufficient. So why is the exponential model greater, which is also the second one on the table? Well, there's not much for us to go on. It's only 1 mark. And so what we do have, though, is we have these coefficient of determination. And you can see here that the exponential is higher. So it's just a matter of us saying here that we have a higher coefficient of determination. could have said a higher R square value. So we're looking at this A value now in our exponential model, and they want us to be able to interpret it. So I'm just going to bring over. So we had that C is equal to 400, and this is just straight from table 8. 475 times by 1.36 t. Now it's good to know how to interpret both of these values. So, and this one here is the A, and then this one here is going to be the B. In this particular question, we only have to interpret the A. And the A value in exponential model is always telling us those initial conditions, but it's saying in the context of the question. So we're going to say that, oops, not the, or could say the, but we're going to say A cat that is 0 years old will have expenses of $475, and that's all that means. Then we're going to use that exponential model now to predict the total cumulative vet costs for someone that does not visit the vet, and it's 15 years. So we're going to say that C is equal to the 475 times the 1.36 up to the power of 15. So 475 times 1.36 up to the power of 15, and we get that the cumulative cost is 47,000, which is quite a lot, 838.46 or 46 cents. Now, we did recognize that was quite a lot of money when we were just doing that question, and that's what part 5 is about. So comment on the reasonableness of your solution. I've kind of pre-filled this a little bit, but I've said that that's probably not reasonable, and it's because we're extrapolating 3 years, right? And sometimes 3 years is okay, but in this case, it actually makes quite a lot of difference in those costs. And so I've done a little calculation here where I've taken that 47,000 that we've just calculated, and I've subtracted away our last set of data. So what I mean by that is if we go back up to the table, our last set of data here was after 12 years, and it was 14,500. So I've subtracted those two numbers, and that's a difference of here $33,000. And so it's saying that in that 3 years, the costs are expected to be $33,000, and that's a lot even for an old cat. So just recognizing that, that's what the reasonableness is about. Down to part C. It says use technology or otherwise, so you could solve this algebraically if you wanted to, but it says find the coordinate of the point of intersection for the linear model and the exponential. I feel like we can probably do this in 2 different ways, but the first way we're going to do it is just going to get the graphs done. So menu, and then we're going to go into graph, and we're just going to enter both of these into y1 and y2. So it's 113x plus 1172 is the first one, and then the second one is 475 times by 1.36 up to the power of x. And then once we graph them, we're just going to find that intersection, and that is not a very good picture. I might just quickly go zoom auto, see if it fixes it up a little bit. Don't really need perfection here. If we just go G-solve and then y-intersect, it should give us what we want anyway. And so I'll just write a comment here saying using GC, t is equal to 3.997, or approximately 4 years, and the cost is equal to 1623.71. All right, and so now we've done that calculation. The whole thing is about, well, do we actually know what that means? Can you interpret? And this is where we've got 2 marks now as opposed to just the 1 mark above for putting some things in a calculator. So I've written it out for us, and I've just said what means that the cumulative cost of vet bills for a 4-year-old cat is going to be that $1,623.71, and this is the cost, and it doesn't matter whether they visit the vet regularly or not. Okay, it's the cost, full stop, because that's where they intersect. And that's the end of question 5.